In this project, we're building a simple LED blinking circuit using a 555 timer integrated circuit, powered by a 9-volt battery and assembled neatly on a breadboard. This classic configuration demonstrates how we can use a 555 timer in astable mode to create a continuous square wave signal, perfect for blinking LEDs or generating clock pulses. Let's begin by identifying the components used in this setup. First, we have a standard 9-volt battery, which provides power to the entire circuit. The red wire is connected to the positive rail of the breadboard, and the black wire connects to the negative or ground rail, establishing the power lines that run across the board. At the heart of the circuit lies the 555 timer IC, an extremely versatile and widely used chip in electronics. It's placed carefully across the center of the breadboard, so each of its 8 pins can be accessed easily. Pins 1 and 8 connect to ground and VCC, respectively. Pin 1 goes to the ground rail, and pin 8 is tied to the positive rail. Pins 4 and 5 are also configured properly. Pin 4, the reset pin, is connected to VCC to disable the reset function, and pin 5, the control voltage pin, is typically unused, but may have a small capacitor connected to ground for stability. Depending on the application, the core timing behavior is set by 2 resistors and 1 electrolytic capacitor. In this circuit, you can see 2 resistors connected between pins 7, 8, and 6. These resistors, along with the capacitor connected between pins 1 and 2, or 6, determine the timing interval for the on and off duration of the output signal. These components work together to charge and discharge the capacitor, which causes the output at pin 3 of the 555 timer to alternately go high and low, creating a pulsing square wave. Connected to the output pin, pin 3, are 2 LEDs, one red and one green. Each LED has its own current-limiting resistor, typically around 220 ohms, to prevent too much current from damaging the LED. These LEDs alternate their state as the output from the timer toggles between high and low. When the output is high, one LED lights up, and when it's low, the other LED turns on. This creates a simple visual indication of the timer's oscillation, effectively making the LEDs blink alternately in a loop. The electrolytic capacitor, which is polarized, is crucial in setting the frequency of blinking. Its value, combined with the resistors, determines how fast the capacitor charges and discharges, and hence how fast the LEDs blink. In this setup, the capacitor is oriented correctly, with its longer positive lead connected to pin 6 and 2, and the shorter negative lead going to ground. This circuit is a perfect demonstration of how the 555 timer can be used in astable mode to create an ongoing pulse without any external trigger. It's often used in light blinkers, tone generators, pulse width modulation, and clock circuits. It's also great for beginners learning how timing components interact in electronics. To sum up, we've used a 555 timer, 2 resistors, 1 capacitor, 2 LEDs with resistors, and a 9-volt battery, all connected carefully on a breadboard to create a continuously blinking LED circuit. This simple yet powerful setup helps us understand timing, wave generation, and the role of passive components in controlling signal behavior. Whether you're a hobbyist or just starting your electronics journey, this project is a must-try and offers valuable insight into real-world circuit building using one of the most iconic ICs in electronics. The 555 timer